In this tutorial, you learn how to detect impacts and light LEDs depending on the crossing of different thresholds. You could of course use other forms of display or sounds, or transmit the data online. In the description below the video, you will find a link to a GitHub repository that includes a wiring schematic, the bill of materials, and detailed explanations for each line of code. But first of all, let's have a look at a bit of theory. Acceleration is the rate of change of velocity, measured in meters per second per second. It has a magnitude and a direction. An accelerometer detects velocity changes in 1, 2 or 3 axes, but for many interactive designs, you are not so much interested in a particular axis. You rather want to find the total acceleration, the acceleration vector magnitude. For that, you must read the values from all axes and apply a formula that integrates them. Depending on the cause of acceleration, the signal will look very different. In our case, we're concerned with impacts, for example from knocks, punches, kicks or tosses. Impact signals are very short impulses, and to evaluate them with multiple thresholds, you'll have to consider the amplitude, rising edge and duration. Depending on the impulse's amplitude, we want to switch on an LED that matches the highest threshold crossed, but you could also play back a sound or do something else. The problem is that after the first threshold is crossed, you can't look into the future to see if a higher one will be crossed, or an even higher one after that. What you can do is to introduce some kind of waiting period that depends on the average impulse signal duration you can establish empirically. Then you can record the highest threshold crossed within that time, while ignoring any glitches on the rising edge, and you know which LED to flash. So, let's have a look at the code to find out how to get this to work. First, you must include the libraries to communicate with the accelerometer, assign an ID, and declare some constant and changing variables. In setup, you initialize the LED output pins, start the accelerometer, and set its sensitivity and sampling rate. In loop, you first take the time and fetch the acceleration vector magnitude with a separate function. You declare a few variables and fetch a sensor event that reads the 3 axis values. Then you apply a formula that calculates the magnitude of the acceleration vector, push negative values to 0, and apply an exponential moving average to smooth the data. Then you convert the result into a threshold value with another function. The function takes the result, a decimal number, depending on the threshold that was crossed, and converts it into a number from 0 to 2 related to the triple LED pin array. Now we use a series of switch case statements, a principle known as state machine, to make sure that the right thing happens at the right time in a controlled way. This is how it works. Depending on the 3 state variables you declared in the enum, only the code of a certain case block will be executed. The break statement directs code execution to the end of switch case, in other words, back to loop. In case start, you check if the lowest threshold was crossed, and if it was, you remember its value and the time when it was crossed. Then you enable case wait, because you need to check if a higher threshold was crossed. If the lowest threshold wasn't crossed, nothing happens and you return to the loop. In case wait, you first check if a higher threshold was crossed. And if it was, you remember its value and the time when it was crossed. You also check if the waiting time is over. And if it is, you switch on the LED that matches the highest threshold that was crossed in the waiting time. You remember the time when the LED was switched on and enable case stop. If no higher threshold was crossed and the waiting time was not over, nothing happens. And you return to loop and get straight to the wait case again because the state variable wasn't changed. In case stop, you check if the LED flash time is over, and if it is, you switch the LED off and enable case start to be ready for the next impact. If the LED's flash time was not over, you return to loop and get straight to the stop case again because the state variable wasn't changed. And that's it. You can set the thresholds to other values for your design, add more thresholds and LEDs, make the thresholds user adjustable, trigger sounds, or do something else. So, let's see the whole thing in action. First, the USB tethered version, so you can observe the total acceleration values in the serial plotter in relation to the 3 thresholds. And here we have a battery-powered version, like you would integrate into a standalone product, like sports, rehab or game equipment. To keep it simple, I kept hardware to a minimum because the clever stuff happens as always in the code. Here's an overview of all parts in case you're not so familiar with them. You'll need the specified components, but you can find cheaper substitutes online. The wiring of the setup is very straightforward. And now it's your turn. Thank you for watching and listening.